Okay, an inverse function is a function that is reversed, that reverses another function. If the function f applied to an input x gives a result of y, then applying its inverse function, the inverse of x, to y gives a result x, and vice versa. So if you plug in a number, you'll get an output number. Does that make sense? And the other one, you plug in that output number into your inverse function, and you'll get the input number. Okay? Which makes no sense to you at all, so we're going to demonstrate. Okay? So this function right here is your function. This graph right here is your inverse function. We're going to write down some ordered pairs for this one. So let's start with our first one is right here. 1, negative 1. When x is 1, y is negative 1. It's not negative 2, but negative 1. When x is, right here is another ordered pair. When x is 0, y is 0 on my function. Then here, I have when x is 1, y is 1. And then we'll go up here. Need another color. Let's get blue. So right here is our other point. When x is 2, y is 4. Any questions over that? Yes.
The first point is you put negative 1, 1.
Thank you. Yes, that's what I meant to do. Right, the x is negative, the y is positive. Any questions over that? Okay, next one. The inverse function, we do the same thing. Here on my inverse, the 0, 0 is also part of it. On my inverse, the 1, 1 is also part of my inverse function. The one that you'll notice the biggest difference is this point right here. When x is 4, y is 2. And you can see the difference. So when x was in my original function, when x was 2, my y was 4. On my inverse function, the x will be 4, then the y will be 2. You basically just switch the x and y values. You don't notice it on 0, 0 because they match. So when I plug in 0, I'm going to get 0. When I plug in 1, I'm going to get 1. Okay? But here, your ordered pairs will flip for the inverse. It'll change. Any questions over that? Okay, let's scroll down. Okay, inverse relation is if A and B is an ordered pair of a relation, then BA is an ordered pair of its inverse. Okay, so the inverse is you just switch the x and y values. So find the inverse of the following relation. Here's my relation when x is negative 1, y is negative 2. When x is 0, y is negative 1. When x is 1, y is negative 1. When x is 3, y is 4. The inverse then would be negative 2 for x and negative 1 for y. So just flip these. When x is negative 1, y is going to be 0. When x is negative 1, y is also 1. When x is 4, y is going to be 3. Any questions over that? We're good? Okay, inverse. Do that same thing, please. So here again, you're just going to switch them. So this is going to be negative 3, 3. This is going to be 7, 6. This is going to be 2, 5. This is going to be 1, negative 2. Any questions over that? We're going to try and do our calculators right now. So I feel like we can put the table in. Might take me a minute to figure out how to do that. Put that down. Okay, turn your calculators. Go home. Okay. Along the home button, while mine turns on, you see at the bottom they have all these different things. Okay, we're going to go down to the bottom, use the arrow button to get there, and then go to the Add Graph to New Document. Okay, it will say Add Graph to New Document. Okay, and we're going to hit Enter on that, and then you should get a screen that looks like this. It's just the graph again. Okay, everyone with me on that? We're going to see if we can get a table. No. Let's go back home again. Do lists and spreadsheets and see if that works. Okay, so you get this. Spreadsheet. Let's do A, where it says the letter A, put X equals X. Then arrow over to B. The very top. Let's get it up here so you guys can see it. Okay, I want this to close. Okay, I'm home. I'm at this. Okay, do you see this? Go up here to where it says equal. Put X there. Then try to arrow over. Nope, don't want this. This is Y. Now let's try and enter our numbers for that. This is all trial and error right now, just so you know. We're going to enter our values. I should probably have my graph here. So enter your function. The X values are -1. I was going to overwrite data in the current columns. Okay. 0, 1, and 3. And the Y value is going to be -2. Push OK. -1. -1. And 4. Okay. Let's see if I have menu. Let's go to menu. Actions. Calculate, move column, insert, data, stat. Oh, let's see table. Switch to table. Okay. No, that didn't work. Let's try that again. Menu. Go to table. Switch to list and spreadsheet. Delete column. Okay, let's escape that, because I don't know what I'm doing. Let's escape that too. Oh, this is a bummer. I felt like this would be easy. There's one. There's one go. Okay, well, I'll figure this out, and we'll try this again later with order pairs. Okay, keep your calculator out right now. We're going to do some graphs. Let me get mine up here. Okay, on our calculators, we're going to graph the function f of x, our function that's on our page. The f of x equals 3x minus 2. We're going to graph that. Okay. We're going to go home again. We're going to go to graph. Okay, I'm just going to give a set. And we're going to type in 3x minus 2. And that's the linear equation, so it's just a line. Very easy. Okay, just put that aside for now. I'm going to come back. And we're going to find the inverse. Okay, so we want to describe the sequence of events that occur when I perform an input value for x on the function. Okay, so if I plug a number in for x, so let's say x equals 2, we want to describe what happens to that 2. So when I plug it in and get f of 2, it's going to equal the 3 times the 2. Minus 2. If I were to solve this, what is the first thing I'm going to do? Class, what am I going to do? Multiply, okay? So describe the sequence of events. I'm going to multiply my number by 3. Does that make sense? That's the first step I would do. Then after I multiply that by 3, what would I do? What am I doing, class? I'm subtracting 2. Okay, in order to find the inverse of that, we're going to do the opposite operation and in reverse order. So I started with multiplying by 3. My first thing I'm going to look at is the last thing I did. My last thing was subtract 2. So what's the opposite of subtracting? Add 2. We're going to add 2 first instead when we do the inverse. Okay, and then what's the opposite of multiply? So we're going to divide by 3. Describe the inverse of each operation in reverse order. That's what we just did. Now we're going to write the rule. We're going to write it as an equation using these steps. So I'm going to have the inverse of x, my inverse function, equals my x value, which I don't know. I'm going to add the 2 first. And then I'm going to divide everything by 3. Any questions over that? Okay, so now we're going to go to our graph. And we're going to enter that in. So remember, you hit your tab button to bring down f of 2. And you enter put it in parentheses, x minus, plus 2, put x plus 2 in parentheses, then move outside of the parentheses to divide by 3. Any questions on how you're supposed to enter this? We're good? And we're going to enter it, and that's my graph. Now, I'm going to make mine have grid. Does yours have a grid still?
Yeah.
Okay, mine does not. View, my grid, line grid. Okay, so this can help us determine the ordered pairs. So right here on my, well, let's start with my original function. This point right here, right, is 0 for x, and then negative 2 for y. So my inverse function should be reverse of that, negative 2, 0. So I come over here at negative 2, 0, and oh, look it, there's my other point. I'm going to find another point on my original function, which is right here. Let's see, I want that colored. And that's at 2, and then, let's see, 1, 2, 3, 4. At 2, 4. Okay, so on my inverse function, I should have 4, 2. So their x is 1, 2, 3, 4, and 1, 2, which is right here. So 4, 2. Now it's nice as we talked about reflecting, right? This is actually a reflection across the y equals x axis. Or if we graph that, let's hit our tab. Let's see, let me go back to this. Tab it. Just put y equals x. Hit enter. Okay. If I fold my paper along this line, my y equals x line, the two lines would overlap, would be the same line. It's a reflection. Inverse functions are just reflections across the y equals x axis. Which is why you'll basically, if you had this, you would see if you folded it in half, it'd be symmetrical. Any questions over that? Okay. How are we doing with this, guys? Is this helping or hurting you, graphing it? Because they're awfully quiet. We're good? Is this easy? Okay. Okay, do the same thing again. I want you guys to describe a sequence of operations performed. If you plugged in a number here, describe what you do first, and then do the inverse of it. Okay, everyone does that right now? Natalie here? Natalie. What did you describe the operations performed on the input of x? What did you do first? Big one. Add 4. Tina, what did you do? Tina, what is the inverse going to be then? That's the opposite of squaring and square rooting. Okay, so the rule for the inverse function is we're going to take x, and have f of inverse of function. With x, you're going to add 4 to it, or sorry, subtract 4. And then take the square root of the whole thing. This is how you write the inverse. So I know it's an inverse function. Okay. Remember, negative exponents like 1 over. This is an inverse. Okay, so we're going to graph it. Okay, hit your tab button. You want to leave f3x equals, or f of 3x equals x. Okay, you want to delete f of 2, get all rid of that. And you want to delete f1. Okay, we're going to enter our original function, which was x squared. Just real quick, what should our graph look like if I'm graphing an x squared? Oh, good, a parabola. And hit enter, and that's what I should get. Okay, then I'm going to hit my tab button again, go to F2, and I'm going to enter in my inverse function, which was the square root. Remember, tab, and then the x squared will give me my square root. X minus 4. And hit enter. And that's that. Hit enter. Okay, so that's what you have. And again, you can see the ordered pairs are going to be in reverse. So this is 1, 2, 3, 4, 0 for x and 4 for y. So this is 4 for x and 0 for y. Again, if I folded that along, I would get this half of my graph. Any idea why I'm not getting this half of my graph? What's my domain here? My x values cannot be negative, right? Because then that will give me a negative number in here. So that's why I'm not getting this part of the graph. It's because I'm limited to only positive values for x. Does that make sense? If I plug in a number less than 4 here, then I get negative numbers inside my radical, and that'd be imaginary. Any questions? Okay. Let's go back. Okay, now instead of describing all that stuff, I'm going to show you another way to find the inverse. You're going to find the inverse of the following function by replacing x and y. Okay, you're just going to switch places with them. So remember, this is like a y value here. So I'm going to have x be here now. I'm going to make it equal to 2, and I'm going to replace it with the y squared, and then plus 3. So I just replaced x and y values, the x and y variables. Now I'm going to solve for y, so I want it to be y equals. So now I'm going to subtract the 3 from both sides. I'm going to get x minus 3 equals 2 y squared. I'm going to divide by 2, divide by 2. And I'm going to get y squared equals x minus 3 over 2. Then I need to take the square root of both sides. And I'm going to get y equals, because I took the square root on this side, and it's an equation, I need a plus or minus sign. Plus or minus the square root of x minus 3 over 2. Any questions over that? When I take the square root in an equation, I need a plus or minus. That's why when we solve an equation, an x squared equation, and I take a square root of both sides, I have a positive number and a negative number. Okay, any ideas? Is this a function? Not sure? Let's graph it. Okay, graphing it will help us see if it is or not. So I'm going to put y tab. I'm going to delete all this stuff. Use my arrows, get up, delete everything. Okay, and we have the square root. Put it in parentheses. X minus 3 no. Move outside the parentheses but not outside the radical. Divided by 2. Okay, there we go. And we're going to put a plus or minus sign in front. Do you have a plus or minus sign? That is such a smart idea. Let's see if I put plus and minus, if that would work. I know he is. Let's see if it's going to like me when I do that. Put a plus sign and a minus sign right here. Let's see if it works so I can do it once. And then enter. No, it says error. Okay, it doesn't like that. So delete that, and we'll do what he said, which is we're going to graph the positive of it And we're going to also graph the negative of it. So hit your tab. Into the same thing, but you're going to do the square root or put negative sign. Use this negative sign. And then the square root in parentheses again. X minus 3. Move outside of the parentheses. Divide by 2. And enter. Okay, so that's my graph. Okay, it's a parabola on its side. Okay, instead of going up and down, it's going to be right and left. Okay, is this a function? Any ideas? Who thinks yes, function? Who thinks no, function? Who's actually not sure? Okay, vertical line test, remember? You take your vertical line. You move it across the graph. Does it hit in two places? Yes, not a function. Vertical lines cannot hit in two places. The x repeats. Remember a function, the x cannot repeat? So here, when x is 1, 2, 3, 4, 5, when x is 5, y is 1 and negative 1. And that's not okay. You can only have one variable. Or one answer for your x, okay? Any questions over that? Okay, try the next one on your own. So right on there. The inverse is not a function. Another way you'll notice without having to graph it is if it has a square root in it, it's not a function. Square roots are not functions. Okay. Okay, this one we do the same thing. We're going to replace our x and our y. I'm going to subtract the 5 from both sides. Oh, sorry. Replace the x and y first. So this is going to be x equals y minus 3 squared plus 5. I'm going to subtract the 5. And get x minus 5 equals y minus 3 squared. Then I'm going to square root. Okay. That's going to give me plus or minus the square root of x minus 5 equals y minus 3. And I add the 3 to both sides. And I get y equals 3 plus or minus the square root of x minus 5. Any questions over that? Okay, yeah. Well, on a test it be like this, because if I put the 3 afterwards, some people might think it's inside the radical with the 5, and I want to make sure you know that the 3 is outside. Okay. Any other questions? Okay, so is this a function class? No, it's not a function because it has a square root in it, and it will be a parabola on its side. And so it will have x repeating. Not a function. Any questions over that? On whatever day that is, Monday? Yeah. I'll check the notes. I don't collect them, right? Sorry, I'm not going to collect them in a second.
Okay.
Okay, so now we're going to do what we did in 7.6, the f of g of x. Okay. So this time, though, we're going to do f of the inverse of negative 3. So before we can find the f of the inverse of 3, you have to actually find the inverse of this. Okay, so we're going to find the inverse of this. So we're going to replace the x and the y here. I'm going to put x equals 4 times y minus 5. I'm going to add 5 to both sides. I'm going to get x plus 5 equals 4y. And divide both sides by 4. I'm going to get y equals x. Sorry, let's not put y. Let's put f of negative 1. So the inverse of x equals x plus 5 over 4. Any questions over that? You okay? Okay. So now we're going to plug negative 3 into the inverse. So we're plug negative 3 in here. So I'm going to get f the inverse of negative 3 equals negative 3 plus 5 divided by 4. So the inverse of negative 3 equals 2 over 4. So the inverse of negative 3 equals 1/2. Any questions on that? Okay, so now you're going to take this and plug it back into our original equation. So I'm going to have f of 1/2 equals 4 times 1/2 minus 5. So this is 2 minus 5. So the f of my inverse of negative 3 is going to equal negative 3. Any questions over that? We're all good? Okay, composition of inverse functions. If f and f1 are inverse functions, then the f of the inverse of x equals x. They will match. Just like they do here, negative 3 and negative 3. Oh, sorry, this should be in parentheses. This will always match. Does that make sense? Because when I plug in an input into an inverse and then back into the original equation, it's just going to be the same. It's like I've done nothing to it. Any questions over that? Okay, you guys can start on some of the homework. You might want to start the review. Since it's right there, you don't have your books with you. Okay, let's see if it's recorded and how well that works. I'm a little confused by that. Can you go back a couple minutes?